Proteins are these wonderful molecules that do almost all of the molecular work of life. So inside cells, you have thousands of these proteins doing their job. Some of them are mechanical jobs like motor parts. Some of them are doing chemistry. Those are the proteins called enzymes. All of these proteins, to do their jobs, need to have very specific folded three-dimensional structures. If they don't have the right structure, then they aren't going to work. So one question is, where would these new structures come from that allow proteins to do new functions? And another question is, can you take one structure that already exists, a folded structure that already exists, and give it a slightly different function, a new function? I refer to these as the big problem and the little problem. One is the big problem of inventing an entirely new protein structure to do something new. And the smaller problem is tweaking in an existing structure so that it does something slightly different. Clearly, one of these is more challenging than the other. And my work early on showed that the bigger problem was beyond the reach of evolution. You have to get too much right in order to get a new structure to form, in order for accidental causes to get these new structures. So my colleagues and I, and Gager in particular, started to look at the smaller problem, which is, can you take an existing folded structure and evolve a new function for it? And somewhat surprisingly, we found that even this smaller problem is too hard for Darwinian evolution, at least in the cases that we've examined. The number of changes you have to make to an existing structure to get a new function to be performed by it is beyond what you can get by random mutation, by Darwinian evolution.